Earth feels immense when we stand upon it. The mountains that rise above us, the oceans that stretch beyond the curve of the horizon, the continents whose distances take hours or even days to cross, all create the illusion that our world is enormous and central. From the ground, we cannot sense the limits of Earth. We only see what is close, and the close feels large. But the moment we step slightly away from the surface, the illusion dissolves. Earth begins to shrink, and with each kilometer upward, our sense of scale unravels. A few hundred kilometers above the ground, the first transformation occurs. From low orbit, Earth becomes a glowing sphere draped in swirling white clouds, wrapped in an atmosphere so thin it appears painted on. Mountains flatten into wrinkles. Continents lose their sharp edges. Everything looks delicate, peaceful, impossibly fragile. The sky that felt infinite becomes a thin veil. Above it stretches a complete, silent blackness that swallows light. Earth no longer feels infinite, it feels finite and exposed. Move farther away, and Earth shrinks again. At the altitude of geostationary satellites, the planet becomes a small, rotating orb. Storms appear as elegant spirals, continents fade into soft shapes. The entire world fits between your fingers. The familiar dissolves into something fragile and bright. Earth is no longer the center of experience. It is simply one object among countless others. From the moon, Earth is smaller still. It rises above a barren horizon as a glowing disk suspended in darkness. For Apollo astronauts, this view was transformative. Earth appeared not as a dominant world, but as a fragile island in a vast ocean. From this perspective, Earth can be hidden behind an outstretched thumb. Everything you know, every life, every memory, reduced to a hovering sphere of light, push outward to the distance of interplanetary probes, and Earth becomes a point of light, a pale, shimmering dot. No continents, no oceans, just a single pixel reflecting sunlight. In the famous pale blue dot image, Earth floats alone in a beam of scattered light, a reminder of how small our world is against the immensity of space. Farther still, past Neptune, past the Kuiper Belt, into the Oort cloud, Earth becomes untraceable. Even the sun shrinks into a star among stars. The solar system becomes a faint glimmer swallowed by darkness. Earth from here is not simply small, it is gone. And yet, this is only the beginning of the universe's scale. The shrinking of Earth is not meant to diminish its importance, but to prepare the mind for a deeper understanding. That scale is not equal to meaning, and that smallness does not erase significance. With each step outward, we reveal the universe's immensity and the extraordinary rarity of the place we call home. Earth feels large only because we live so close to it. But distance reveals the truth, a truth both humbling and beautiful. The world becomes smaller not to make us feel unimportant, but to expand our perspective, to reveal the immense canvas of existence and the fragile miracle of this tiny, living world. As we move beyond the distance where Earth disappears from sight, a new layer of perspective begins to unfold, one that shifts our understanding from the personal to the planetary, from the familiar to the incomprehensibly vast. The shrinking of Earth continues not because the planet changes, but because the universe around it grows at a rate that overwhelms the imagination. What felt enormous from orbit becomes insignificant when placed beside the titanic bodies that populate our own solar system. This is where the true unraveling of scale begins, where Earth transitions from a world to a detail, from a detail to a speck, and from a speck to something almost mathematically irrelevant. The first giants that erase Earth are the gas planets. Jupiter, a world so massive that more than 1,000 Earths could fit inside it. dominates the solar system like a cosmic colossus. Its storms, larger than our entire planet, spin for centuries. Its magnetic field is so immense it creates radiation belts that would be deadly to humans. When Earth is placed beside Jupiter, the comparison is almost absurd. Our world becomes a bead next to a planet the size of a god. Saturn, with its glorious rings stretching hundreds of thousands of kilometers, diminishes Earth even further. The rings alone, thin, delicate bands of ice and dust, could swallow our planet several times over. Uranus and Neptune, colder and more remote, continue the trend. Earth, so full of life and complexity, looks like a small moon among worlds that dwarf it effortlessly. But the true moment of insignificance comes when we place Earth beside the Sun. Our star is the anchor of our solar system, a roaring furnace of plasma so vast that over 1 million Earths could be packed inside it. Solar flares erupt with the energy of billions of nuclear bombs. Sunspots the size of planets drift across its surface. The granules of boiling plasma rising and falling on the photosphere are each larger than Africa. Everything on Earth, every life, every structure, every moment, exists because of this single star's steady blaze. And yet, the Sun is not large. Not truly. It is a medium-sized, ordinary star in a galaxy filled with behemoths. Compare the Sun to Sirius, Vega, or Deneb, and it shrinks further. Compare it to Betelgeuse, Antares, Mu-Cephei, or Stephenson 218, and the Sun becomes a spark beside a burning world of unimaginable size. Some of these stars, if placed at the center of our solar system, would swallow Mercury, Venus, Earth, Mars, and even Jupiter. The orbits of planets become trivial inside the swollen atmospheres of these stellar titans. Earth does not simply shrink in their presence. It vanishes into their outer layers, its orbit swallowed whole by their incandescent borders. From here, the shrinking accelerates. Individual stars, no matter how large, become insignificant when placed inside the Milky Way. Our galaxy, a spiraling city of hundreds of billions of stars, stretches 100,000 light-years across. The Sun is merely one lamp in this vast metropolis. Earth, so tiny already, becomes an invisible passenger orbiting a star that does not stand out in any way. One of countless points of light scattered through a disk of swirling brilliance. The Milky Way is not a chaotic cloud of stars, but a structured, gravitational machine. Spiral arms twist outward in luminous arcs. Dense nebulae shine like cosmic lanterns. Star clusters glitter close together in tight spheres. Black holes lurk silently, shaping the paths of stars around them. And Earth? Earth cannot be seen at all. No map of the galaxy marks its location. No visualization can plot it. Even the entire solar system is far too small to appear as more than a mathematical placeholder. Zooming out once more reveals something even larger. The local group, a collection of more than 80 galaxies bound by gravity and drifting together through space. The Milky Way and Andromeda, the two giants of this cluster, will collide in several billion years. Around them swarm dwarf galaxies, small, faint collections of stars, barely luminous enough to be detected. Earth, already erased within its own galaxy, becomes even smaller here. The Sun is lost in the blur of stellar populations. The solar system disappears completely. Zoom farther still, and the local group becomes a speck within the Virgo supercluster, a gravitational basin containing thousands of galaxies spread across hundreds of millions of light years. What once felt infinite now becomes a small region within a larger structure, and Earth becomes a concept too tiny to map, too faint to imagine against the roaring scale of existence. And beyond even this lies the cosmic web, a vast network of filaments stretching across billions of light years. These filaments, formed of galaxies, clusters, and superclusters, span distances so enormous that human language fails to convey their true size. Massive voids, larger than anything we can emotionally grasp, punctuate the structure like cosmic caverns. The Milky Way is just a tiny bead on one strand of this web. The entire local group is a dot. The Virgo supercluster becomes a fraction of a thread. Earth is nowhere. Yet this realization does not inspire despair. Instead, it deepens the mystery. Because despite the vastness, despite the overwhelming scale, despite the indifference of space, Earth remains the only place we know where matter has woken up, where atoms have organized themselves into life, thought, and awareness. This smallness prepares the mind for a deeper transformation ahead, one that goes beyond physical dimensions. The journey outward continues, not to make Earth feel unimportant, but to reveal what makes it extraordinary. As the universe expands around us, the dissolution of Earth's scale continues. But now, something new begins to shift. The perspective stops being purely physical. It starts to become existential. Distance alone no longer explains the shrinking. What emerges instead is a deeper realization. Earth is not only small in space, but also fleeting in time. The cosmic timeline dwarfs our world in a way even more dramatic than the spatial vastness we've explored. And when we place Earth against the full length of cosmic history, its existence becomes not just tiny, but astonishingly fragile. The universe is 13.8 billion years old. Earth formed around 4.5 billion years ago, more than 9 billion years after the Big Bang. By the time our planet emerged from the swirling remains of earlier generations of stars, the Milky Way had already completed multiple rotations. Stars had lived and died. Entire stellar nurseries had formed and dispersed. Galaxies had collided, merged, grown, and reshaped themselves. Earth, in this context, is a late arrival, a newcomer in a universe already ancient. But the shrinking intensifies when we consider the timeline of life. For nearly 1 billion years after forming, Earth was a molten, chaotic sphere, not a place where life could exist. When life finally appeared, it was simple, microscopic, and astonishingly durable. Microbial ecosystems dominated Earth for more than 3 billion years. Through volcanic upheaval, asteroid impacts, shifting continents, ice ages, and periods of intense heat, life survived. But it remained small, unseen, uncomplex. The world we know today is the result of a long chain of improbable events. Multicellular life, the diversity of organisms we recognize, did not appear until around 600 million years ago. The Cambrian explosion, a rapid burst of evolutionary complexity, fills only a tiny sliver of Earth's history. Dinosaurs ruled the Earth for 165 million years, an era far longer than the entire existence of humans. But even their reign represents only a whisper compared to the age of the universe. Human beings, Homo sapiens, appeared roughly 300,000 years ago. In cosmic terms, this is less than the blink of an eye. All of recorded human history fits into the last 10,000 years. The modern world, the technologies that define our lives, the systems we rely on, the stories we tell, has existed for only a few hundred years. If the entire history of the universe were compressed into a single year, humans would appear in the final seconds of December 31st. Time reveals something space cannot. Earth is not simply small, it is ephemeral. The conditions that allow life, much less intelligent life, are temporary. Earth orbits a sun that changes slowly but relentlessly. Solar luminosity increases over time, and within 1 billion years, Earth's temperatures will climb high enough to evaporate oceans and strip away habitability. Long before the sun becomes a red giant, Earth will have already become too hot for life as we know it. Eventually, the sun will swell, shedding layers of plasma, perhaps engulfing Earth entirely. Whether the planet is swallowed or merely scorched, life will be erased. In the far future, star formation across the universe will slow and eventually cease. Galaxies will drift apart as dark energy stretches space. Stars will die, their remnants cooling into black dwarfs that fade into invisibility. Black holes will dominate the universe until even they evaporate. The cosmos, expanding endlessly, will move toward a cold, thin darkness where nothing new forms and nothing remains to perceive the silence. Against this timeline, Earth becomes a temporary eddy in a cosmic river, a brief interruption in an otherwise smooth flow of increasing entropy. And yet, this brevity is precisely what makes life so extraordinary. The fact that awareness emerged at all during this narrow, improbable window is a phenomenon so rare that its smallness becomes a kind of miracle. What makes Earth unique is not its size. It is the fact that, amid billions of years of cosmic silence, this tiny world briefly awakened. Matter learned to think. Atoms became aware of their own origins. The universe, for a moment, looked back at itself through human eyes. This realization begins to shift the effect of Earth's smallness. The shrinking does not diminish meaning, it expands it. For the first time, we see Earth not as the center of creation, nor as a trivial rock lost in space, but as a delicate cradle where consciousness emerged in defiance of cosmic vastness. And this perspective prepares us for the next leap, where the very laws of physics begin to dissolve the boundaries of what small even means. Earth becomes not just a small world in a large universe, but a rare event in a universe where rarity itself is profound. And as we continue outward, the structure of the cosmos will reveal something even stranger. The universe around us may not be the only one. As the boundaries of space and time stretch farther than anything Earth could ever visibly inhabit, a subtle tension begins to build. Until now, the shrinking of Earth has been gradual, almost gentle, a slow dissolution of scale as the universe widens around it. But something shifts as we move deeper into the galactic and intergalactic structures. A realization emerges, one that quietly rewrites everything we thought we understood about our place in the cosmos. This is where the first twist reveals itself. Not a sudden shock, but a deep, unsettling change in perspective. For most of human history, the universe was imagined as a tidy, comprehensible place. A sun in the center, planets moving in predictable circles, stars scattered across a dome of sky. Even when we learned that the universe was far larger than we imagined, we still assumed it was centered around something meaningful. Around light, around mass, around galaxies, around gravity. But the deeper we look, the stranger the structure becomes. Our galaxy, for all its grandeur, is not a dominant force. It is a single thread woven into a cosmic web so vast and so intricate that even the most enormous galaxies are merely tiny nodes in its latticework. The discovery of this web is one of the greatest revelations in modern cosmology. Galaxies are not scattered randomly through space. They gather in chains, filaments, stretching across billions of light years. These filaments intersect at dense hubs called clusters, where thousands of galaxies are bound together by gravity. Between the filaments lie enormous voids, regions so empty that entire galaxies can pass through them without encountering a single star. The scale of these voids defies comprehension. Some are hundreds of millions of light years across, large enough to swallow not only the Milky Way, but the entire local group and its neighboring clusters. In this grand architecture, Earth is not merely small, it is erased. The solar system is unmarked. The sun is a faint point. The Milky Way itself blends into the luminous threads of the cosmic web. Even galaxy clusters, these colossal gravitational anchors, fade into the larger structure. What remains visible is not matter, but pattern. The universe becomes a geometry of brilliance and emptiness, a tapestry woven by forces older than stars. Earth is nowhere to be found in this structure. Not lost, simply irrelevant to the scale at which the universe arranges itself. This is the first revelation. The universe does not organize itself around Earth or the sun or even galaxies. It organizes itself around something invisible, dark matter. This is where the twist emerges. For all our observations, for all the beauty of stars and nebulae, most of the universe is made of something we cannot see. Something that does not emit, absorb, or reflect light. Something detectable only by its gravitational pull. Dark matter shapes galaxies, forms filaments, and sculpts the cosmic web. Without it, the universe as we know it would not exist. And Earth? Earth is made of the other kind of matter, the rare kind. The kind that glows, the kind that interacts, the kind that forms atoms, chemistry, and life. But this familiar matter, everything we see, touch, and experience, makes up less than 5% of the universe. The rest is dark. This is the twist hidden in plain sight. Earth is composed of the minority ingredient in a universe built mostly from something else. The matter we know is unusual. The matter we are made from is not the rule, but the exception. Earth is not simply small. It is composed of rare cosmic material. But the revelation does not end there, because beyond dark matter lies something even more dominant, something that stretches the universe itself. Dark energy. The mysterious force that accelerates cosmic expansion. Dark energy makes up nearly 70% of the cosmos. It drives galaxies apart, pushes clusters away from each other, and thins the cosmic web over time. In the distant future, it will isolate every galaxy, every star, every world. The universe will expand beyond visibility, leaving observers alone in a silent, darkening void. This is the deeper twist. The universe is not only vast, it is changing. And the forces that shape it are not visible, not intuitive, and not friendly to permanence. Earth's smallness is amplified by the realization that the universe is not stable. It is a moving, expanding, accelerating system. Space stretches. Time evolves. Structures disperse. Earth is not only tiny, it is temporary in a universe where even galaxies are not forever. Yet, as the universe grows darker and the scale grows larger, something remarkable emerges from the very fragility of Earth. The world that shrinks so dramatically under the weight of cosmic vastness becomes more precious, more improbable, and more meaningful. Earth may be invisible in the cosmic web, but it remains the only place we know where matter has become able to reflect upon its own existence. The journey forward will take us even farther, from the edge of the observable universe to the boundaries of what might lie beyond. But before that, we must understand that Earth's smallness is not a flaw. It is a perspective. And perspective is the key to unlocking everything that follows. As we push deeper into the cosmic landscape, the scale we have confronted until now begins to feel strangely familiar. Because the human mind adapts quickly once Earth has shrunk and vanished into the cosmic web. Once stars have become sparks and galaxies have dissolved into threads, we find ourselves searching for meaning in structures so vast they barely feel real. But now begins the phase where the complexity of the universe stops expanding outward and instead starts folding inward, revealing hidden layers of order, rhythm, and connection. This is where the journey transitions from the visible universe to the invisible mechanics holding everything together. And in this shift, Earth takes on an even stranger, more humbling form. At first glance, the universe appears to be shaped entirely by gravity. This silent, persistent force sculpting the motion of planets, stars, and galaxies. But gravity is only one part of the cosmic machinery. The deeper truth is that reality is structured by a delicate interplay of forces so precisely balanced that if even one were slightly different, Earth could not exist. This is where the scale of the universe becomes less about size and more about conditions. Conditions that define what can live, what can form, and what can remain stable long enough for consciousness to appear. Begin with the strong nuclear force, the most powerful known force in nature. It binds protons and neutrons inside atomic nuclei. If the strong force were slightly weaker, atoms would fall apart. If it were slightly stronger, stars could not fuse elements to produce the building blocks of life. The balance is razor thin, and Earth exists only because this balance holds. Then consider the electromagnetic force, responsible for chemistry itself. Everything from the DNA in your cells, to the water in the oceans, to the light emitted by the sun. A small change in the strength of this force would alter the structure of atoms and prevent stable molecules from forming. Without stable molecules, no oceans, no oxygen, no carbon, no life. Earth exists because electromagnetism is tuned just right. Gravity is even more peculiar. It is unimaginably weak compared to other forces. A child's toy magnet can defeat the gravitational pull of the entire planet. If gravity were only slightly stronger, stars would burn too quickly for life to evolve. If it were slightly weaker, stars would never ignite at all. Earth requires a gravitational balance so precise that it falls within a cosmic fraction almost too small to measure. And then there is the weak nuclear force, the quiet mechanism that allows elements to change identity inside stars. Without this force, the chemical richness of the periodic table would not exist. Stars would not produce the diversity of elements needed to build planets, oceans, and living cells. Earth, once again, exists only because this delicate interaction operates exactly as it does. Here is where the shrinking of Earth transforms into something else entirely. When viewed through the lens of cosmic forces, Earth does not only become small, it becomes improbable. The conditions necessary for a world like ours sit in a narrow crack between universes that collapse instantly and universes that never form structure at all. Earth lives in a cosmic balance that allows complexity, chemistry, and stability to coexist. It is not just tiny. It is unlikely in a way that defies intuition. But improbability grows even deeper when we consider the universe's expansion. Dark energy, the mysterious driver of cosmic acceleration, is tuned with extraordinary precision. If dark energy were slightly stronger, matter would never have clumped into galaxies. If it were slightly weaker, the universe would have collapsed long before stars could form. The existence of any galaxy, much less a star like the Sun or a planet like Earth, is perched on the edge of a cosmic knife. This paints a picture of reality that is startling. Earth is not only small in size and short-lived in time, it is balanced on a delicate architecture of cosmic rules that could easily have failed to produce anything stable. And yet, somehow, within this narrow window, life flourished. Consciousness emerged. The universe became aware of itself in the form of living beings standing on a world that should not, statistically speaking, exist. But the shrinking continues. Once the forces are understood, Earth dissolves even further into the quantum world. At the smallest scales, particles lose their solidity. They behave as waves, probabilities, and flickering excitations of underlying fields. The atoms composing Earth are mostly empty space. The solidity we perceive is not a physical property, but a quantum interaction preventing electrons from occupying the same state. Earth is not a solid world. It is a pattern, a temporary arrangement of energy in a universe where nothing truly holds still. This realization leads to something profound. The physical smallness of Earth becomes intertwined with the fragility of existence itself. The universe permits life not because life is inevitable, but because the laws of physics allow a brief moment when complexity is possible. Earth is part of that moment. And the deeper we examine the machinery of reality, the more we understand that this small, fragile world is astonishing not despite its size, but because of it. What lies ahead, however, stretches this idea even further. Because once we understand the delicate forces that hold the universe together, we must confront something even stranger. The possibility that the universe we inhabit is only one configuration among countless others. And in that greater landscape, Earth becomes not just improbable, but nearly impossible. This is where the journey will next lead, into a reality far larger and far stranger than the one we see. As we continue to peel back the layers of the universe's structure, the sense of scale that once felt overwhelming now becomes strangely familiar. What once shocked us begins to settle into a pattern, and the mind adapts, stretching itself to accommodate distances that defy ordinary comprehension. But this stage of the journey reveals something different, an emotional and psychological weight that grows with every step outward. It is here, in this widening expanse, that the shrinking of Earth becomes not just a physical phenomenon, but a profound shift in how we perceive existence itself. The further we go, the more the loneliness of the cosmos becomes apparent. In the vast dark between galaxies, there is no air, no sound, no warmth. Space is not empty. It is silent in a way that erases the concept of presence. The distances become so great that light, moving at the fastest speed possible, needs millions or billions of years to travel from one place to another. The universe stretches not like a map, but like a living organism pulling itself apart. And Earth, drifting on its quiet orbit, becomes a temporary ember in a sea of growing darkness. Consider what happens when we move beyond the scale of the cosmic web. Even the enormous filaments, each filled with clusters and superclusters of galaxies, begin to dissolve into something even more abstract. The observable universe, a sphere around us with a radius of roughly 46 billion light-years, is itself only a temporary bubble, carved out by the limits of light and time. Everything inside it is the part of the universe we can see, not because that is all that exists, but because light from beyond that boundary has not yet reached us. Earth lies at the center of this sphere, not because Earth is special, but because every observer becomes the center of their own observable universe. This is where the shrinking grows heavier. Earth is not simply small. It exists inside a boundary created by the finite speed of light and the age of the universe. The observable universe is not the whole universe. It is only the region that has had enough time to make itself known to us. Beyond it may lie regions so vast and so different that our entire cosmic bubble could be nothing more than a microscopic fraction of a much larger reality. And yet, within this bubble lie 2 trillion galaxies, each containing hundreds of billions of stars, each with planets, moons, and debris swirling around them. The numbers overwhelm the mind. If every grain of sand on Earth represented a planet, the beaches of the world would not contain enough sand to match the number of planets in the observable universe. In such a landscape, the meaning of smallness becomes almost abstract. Earth is reduced not only physically, but statistically. The probability of this world, with its delicate balance of conditions, seems impossibly low against the backdrop of so many stars and worlds. But even this vast number of worlds does not offer comfort. For despite the countless planets that must exist, life remains undetected. Not a single signal, not a single confirmed biosignature, not a single trace of civilizations, nothing but silence. This lack of evidence presses on the mind like a weight. It suggests that life, even microbial life, may be far rarer than we imagine. The cosmic silence becomes a kind of tension, a quiet pressure that turns Earth from a tiny world into an improbable miracle. That tension deepens when we consider how much of the universe is hostile to life. Most stars are unstable. Many planets orbit too close or too far from their suns. Many regions of space are bathed in radiation from massive stars or wandering black holes. Even Earth, stable as it is, has survived asteroid impacts, volcanic cataclysms, ice ages, and fluctuations in solar output. Life has persisted here, not because the universe welcomes it, but because Earth has endured in spite of the universe's indifference. And yet, even endurance is fragile. Earth's orbit is stable only because giant planets shepherd it. Its seasons depend on the moon stabilizing its tilt. Its climate hinges on a narrow band of atmospheric chemistry. The rarity of these coincidences becomes clearer the deeper we explore the cosmos. The conditions that allow life are not universal. They are narrow, specific, fleeting. Earth exists in a temporary corridor between creation and destruction. But the most profound shift occurs when we consider the future. The universe is expanding, and the expansion is accelerating. Galaxies are drifting apart and moving faster with time. Eventually, nearly all galaxies beyond the local group will vanish from view. Not because they cease to exist, but because space between us expands faster than light can cross it. The observable universe will shrink to a lonely island of stars bound by gravity. Future civilizations, if any survive, will see only their local galaxies. They will never know the universe was once filled with trillions of galaxies. Earth exists during a rare, privileged moment in cosmic history, a time when the universe is still visible. This realization brings a new weight to the shrinking scale. Earth's smallness is not only spatial and temporal, it is historical. We live at a moment when the universe is illuminated, when galaxies are still within reach of our telescopes, when the cosmic web is still visible. In the far future, the universe will grow dark and quiet, and the larger structure will fade from detectability. Earth's era is not merely small. It is fleeting, like a single sunrise before an endless night. And yet, this growing silence reveals something deeply poetic. The universe may be vast, hostile, and indifferent, but life emerged anyway. It emerged here on this tiny world, during this brief window, with these specific conditions. And in doing so, it gave the cosmos something it otherwise lacks: awareness. This improbable awareness transforms the shrinking of Earth from a story of insignificance into a story of rarity. But the journey is not over. The shrinking will intensify again, shifting not from physical scale or cosmic history, but from the very fabric of reality. Because beyond the visible universe lies something stranger, a landscape where the rules may break, where the universe we know may be only one version of countless possibilities. Earth, in that greater expanse, becomes not just small, but nearly impossible. and this prepares us for the turn that follows. As we approach the threshold between what we can observe and what we can only imagine, the universe begins to shift again. The vastness we have traveled through, the planets, the stars, the galaxies, the cosmic web, the observable horizon, has already dissolved Earth into a mathematical whisper. And yet, all of it, every structure we have considered so far, shares a common truth. It belongs to a single universe, one set of physical laws, one cosmic history, one fabric of space-time. But now comes the moment when this assumption fractures. Here, the journey takes its first major turn. The scale stops growing outward and instead multiplies sideways into possibilities. The first great twist is this: the universe we see may not be the universe that is. For decades, scientists assumed the Big Bang created the entirety of existence. A single explosion, a single expansion, a single cosmos containing everything. But modern physics paints a much stranger picture. According to inflation theory, the universe did not expand evenly. Instead, space inflated in patches. Some regions expanded rapidly and continued expanding forever. Other regions stabilized and cooled, becoming bubble universes. Ours is only one of them. Imagine boiling water. Bubbles form on the surface, separate, distinct, each carrying its own environment. Now imagine each bubble as a universe, sealed away from all the others. Our entire observable reality, trillions of galaxies, billions of years, everything we know, could be only one bubble in cosmic foam. Suddenly, the meaning of scale changes entirely. Earth is small in the Milky Way. The Milky Way is small in the local group. The local group is small in the Virgo supercluster. The Virgo supercluster is small in the cosmic web. The cosmic web is small in the observable universe. And the observable universe itself may be small in something vastly larger. This is where smallness becomes something new. In the multiverse picture, our universe is not the default. It is one configuration among potentially infinite configurations. If inflation never completely ends but continues eternally, then bubble universes form endlessly, each with its own laws of physics. Some may collapse instantly. Others may never form stars. Some may have stronger gravity, others weaker. Some may host dark energy so powerful that matter cannot clump. Some may allow structures and life in ways impossible for us to imagine. The physics of our universe, the precise strengths of forces, the masses of particles, the behavior of fields, is not just balanced, it may be selected. Not by intention, but by possibility. In a landscape of countless universes, Earth becomes improbable on a cosmic scale and nearly impossible on a multiversal scale. The twist cuts deeper the more we consider it. Everything that makes Earth stable, its orbit, its chemistry, its star, depends on physical constants that, in many universes, may not allow planets at all. If the electron were slightly heavier, atoms would collapse. If dark energy were stronger, galaxies would never form. If the strong nuclear force were weaker, hydrogen would be the only element. Earth's smallness is no longer about size, but about existence. It is not only tiny, it is shockingly rare. But rarity becomes something stranger still when we explore the consequences of infinity. If the multiverse is infinite, then every possible arrangement of atoms may exist somewhere. Not just Earth-like planets, but Earth itself. Duplicates created not by connection, but by probability. In an infinite reality, patterns repeat, histories repeat, worlds repeat. Even consciousness may emerge in endless variations. This concept is not science fiction. It is a mathematical consequence of infinite space and finite combinations of matter. Somewhere, In some distant universe, there could be a planet identical to Earth, down to the arrangement of every molecule. Somewhere else, a world almost identical, with tiny differences. And somewhere else, unimaginable forms of life could emerge under different structures of physics. But this is where the twist becomes emotionally significant. Because if countless universes exist, some like ours, some utterly alien, then meaning cannot come from comparison. Not from size, not from age, not from rarity. Meaning becomes local. Meaning becomes internal. Meaning becomes something Earth generates, not something the universe assigns. This is the point where the shrinking of Earth begins to flip. The world that seemed erased by the cosmic scale now becomes important again. Not because it is large, but because it is aware. In a multiverse filled with silent universes that never formed complexity, Earth is extraordinary. A place where physics allowed life, and life allowed thought, and thought allowed wonder. The journey ahead will continue expanding this idea. Now that Earth has dissolved into a multiverse of possibilities, the next step is to explore what happens when the universe itself begins to fade. When cosmic time overtakes cosmic space, and existence becomes something that must be understood not in distance, but in meaning. This is where the shrinking becomes something else entirely. Not a loss, a revelation. As the idea of a multiverse settles into place, the universe we once believed to be infinite and all-encompassing becomes just one possibility among countless others. And with that shift, something subtle but profound begins to happen. The focus of our journey changes. No longer are we merely shrinking Earth by comparing it to larger and larger structures. Now we are peeling away layers of assumption, revealing that the very framework within which Earth exists might not be the only one. This is where the story becomes not just cosmic, but philosophical, not just physical, but existential. Here we step into the deepest part of the narrative, the place where the universe reveals its quiet, hidden architecture, and Earth dissolves into the strangeness of reality itself. To understand the full meaning of Earth's smallness, we must go beyond planets and galaxies, beyond the cosmic web, beyond even the observable universe. We must examine the invisible patterns that determine what can exist at all. And in doing so, we discover that existence is built on something far more fragile, far more intricate, and far more temporary than it appears. Begin with the quantum fields, the invisible vibrating energy structures that underlie everything in the universe. According to quantum field theory, the universe is not made of particles, but of vibrating excitations in fields. The electron field, the quark field, the photon field. These fields span all of space. Particles appear only when these fields vibrate in specific ways. Earth, then, is not a solid object. It is a temporary arrangement of vibrations, patterns in the fabric of reality. The stability of these patterns depends on mathematical relationships so precise that even the slightest variation would erase them instantly. Change the mass of the electron by a fraction, and atoms collapse. Alter the strength of electromagnetism, and chemistry fails. Modify the rate of cosmic expansion, and galaxies either never form or collapse immediately. Earth exists in a razor-thin region of possibility, a narrow sliver in the infinite landscape of what could have been. But even this precision is not the deepest strangeness. Beneath the quantum fields lies another structure, space-time itself. The fabric of reality bends, curves, stretches, and ripples in response to mass and energy. Black holes form where space-time folds into singularity. Gravitational waves ripple outward when massive objects collide, stretching and compressing the fabric of the universe. Earth orbits the Sun not because of a force pulling it, but because the Sun curves space-time, and Earth follows the simplest path in that curved geometry. Time, too, is not absolute. It flows differently near massive objects. It stretches and compresses. At the event horizon of a black hole, time stops entirely from the perspective of an outside observer. Earth exists in a region where time flows gently, steadily, a rare and peaceful corridor in a universe where time itself can break. The deeper we go into these foundational layers, the more Earth dissolves. It stops being a planet. It stops being matter. It becomes a pattern of vibrations and fields arranged in a specific region of curved space-time, sustained by the delicate balance of physical laws. Its smallness is not just spatial or temporal, it is structural. The universe is not required to permit planets, biology, or consciousness. And yet, it does here, in this one place, during this fleeting moment. Now zoom outward again, not physically, but conceptually. Consider entropy, the measure of disorder in a system. The universe began in a state of extremely low entropy, smooth, uniform, and hot. As it expanded and cooled, structure formed, stars ignited, galaxies spun, planets condensed. But all of this is temporary. Over time, entropy increases. Stars burn through their fuel, galaxies disperse, black holes evaporate. Eventually, the universe drifts toward a cold, dark equilibrium, a state in which no energy gradients exist and nothing new can happen. This is the heat death, the final consequence of entropy's rise. From the perspective of entropy, Earth is an island of improbably low disorder, a brief flash of complexity in a universe that is tending toward simplicity. Life itself is a rebellion against entropy, a local defiance of the cosmic trend toward disorder. But even this defiance is temporary. Life requires energy flows, sunlight, chemical gradients, geothermal heat. As the universe ages, these flows diminish. Earth's complexity is a brief exception, a momentary anomaly in a cosmos overwhelmingly hostile to the persistence of structure. And here, the emotional weight of the narrative deepens. Earth is not just small. It is temporary in every dimension: space, time, structure, and probability. It is a flicker. Yet, paradoxically, this fleeting nature is what gives Earth its significance. Against the vast backdrop of the cosmos, Earth is one of the few places where entropy runs backward, where matter organizes itself into something capable of reflection, memory, and awareness. The universe may be enormous, and Earth may be microscopic within it. But Earth holds something the universe rarely shows: the ability to think about itself. This is where the concept of smallness flips once more. Earth is insignificant cosmically, but extraordinary existentially. It is a place where atoms, which spend most of cosmic history drifting in silence, have arranged themselves into something capable of asking questions, something capable of feeling wonder, something capable of seeking meaning. And this shift from scale to consciousness marks the turning point that prepares us for the next stage of the journey. Because if Earth is this small, and if the universe is this vast, and if the multiverse is this immense, then the question changes entirely. Smallness stops being a measure of unimportance. It becomes a measure of rarity, of delicacy, of preciousness. And as we step toward the final arcs of this journey, the universe begins to reveal that the most extraordinary thing about Earth is not how tiny it is, but that anything like it exists at all. As we move closer to the edge of everything that the universe allows us to see and understand, the sense of scale we have carried throughout this journey begins to shift again. Up to this point, Earth has been dissolving, First into the cosmic landscape, then into time, then into the improbable machinery of physics, and finally into the even larger possibility of a multiverse. But now something new begins to happen, something more subtle and more profound than the shrinking itself. The universe stops overwhelming us with size and starts overwhelming us with silence. The further outward we travel, the quieter everything becomes. Not quiet like a still forest or a sleeping city, but quiet in a way that removes the idea of sound entirely. Beyond the stars and galaxies, beyond the glowing arcs of filaments, beyond the distant clusters whose light has taken billions of years to reach us, lies a profound emptiness. Space is not simply large, it is sparse. Even inside the cosmic web, most of space contains nothing. No stars, no planets, no gas, no dust. Nothing but a handful of atoms drifting through an expanse so vast that their presence becomes mathematically irrelevant. This emptiness grows heavier the more we contemplate it. The observable universe contains trillions of galaxies. Yes, but these galaxies occupy far less than 0.001% of the universe's volume. The rest is darkness. The rest is cold. The rest is silence. Earth, once a vibrant world full of motion and noise, shrinks into this silence as if swallowed by it. The more we zoom out, the more it becomes clear that life is not simply rare. It is surrounded by a cosmic ocean of nothingness. But emptiness is not the only force reshaping our understanding here. The expansion of the universe is accelerating. Galaxies are receding from one another faster and faster, driven by dark energy. This acceleration creates a strange and unsettling truth. The universe is not only vast now, it is becoming more vast with every passing moment. The farther a galaxy is from us, the faster it is being carried away by the expansion of space. Many galaxies are already receding faster than the speed of light, not because they are moving through space, but because space itself is stretching between us and them. This leads to one of the most haunting realizations in cosmology. We are losing the universe, not metaphorically, literally. Galaxies that are visible to us today will one day fade beyond the cosmic horizon, carried away so rapidly by expansion that their light will never reach us again. Over cosmic time, the night sky will grow emptier. First, distant galaxies will dim, then clusters will vanish. Eventually, only the galaxies bound to our local group will remain. Billions of years from now, observers in the Milky galaxy, the future merger of the Milky Way and Andromeda, will see a sky with no evidence of the cosmos beyond. Earth exists at one of the rare moments in cosmic history when the universe is still visible. This is not a poetic exaggeration. It is a scientific fact. We live during the era of light, the brief cosmic window when stars still shine, when galaxies are still bright, when the cosmic web is still illuminated. In the deep future, the universe will become a dark, cold, isolated place where nothing new forms. The structures that today define the cosmos will no longer be observable. And Earth, this tiny world, this fragile point of awareness, experiences the universe at its brightest, its most structured, its most beautiful. The shrinking of Earth becomes intertwined with the shrinking of the universe's visible past. The smallness of Earth is not only spatial or temporal, it is situational. We occupy a unique moment in cosmic history, one that will never come again. The silence deepens even further when we consider the fate of stars. They are finite. They burn their fuel and die. Small stars fade into dwarfs. Large stars die in catastrophes, supernova, hypernova, black hole births. New stars will continue to form, but not forever. Eventually, star formation will cease. Galaxies will exhaust their gas. The universe will transition into the degenerate era, where white dwarfs cool into black dwarfs, neutron stars drift silently, and black holes dominate the gravitational landscape. Against this timeline, Earth is a flash, a moment, a brief symmetry in chaos. And yet, amid all this shrinking, amid all this dissolution into silence and emptiness, something remarkable becomes clear. The universe is not hostile to life, but indifferent. And that indifference makes the existence of anything as complex as Earth, and anything as conscious as humans, profoundly unlikely. This is where smallness begins to bend, not into despair, but into revelation. Because if Earth is this small, and if the universe is this vast and this silent, then the emergence of awareness, the ability to understand, to question, to contemplate, becomes not trivial, but extraordinary. Silence gives meaning to sound. Darkness gives meaning to light. Vastness gives meaning to existence. Earth's smallness is the backdrop that makes consciousness rare and therefore remarkable. This realization takes us to the threshold of the final act. Earth has shrunk across distance, across time, across physics, across possibility, across probability, across visibility. And now, as we stand at the edge of the observable universe, with silence surrounding us and cosmic expansion pulling the stars away, the question deepens beyond scale. If Earth is this small, then why does it matter at all? The answer is close, and it will change the meaning of smallness forever. As we cross the threshold into the final arc of this journey, everything we have uncovered so far converges into a single, profound moment of realization. The shrinking of Earth has taken us across unimaginable distances, through incomprehensible structures, into the machinery of physics, the silence of the cosmos, and the possibility of endless universes. And yet, the most transformative shift is still ahead. It does not come from distance or time, nor from galaxies or quantum fields. It comes from something far more fundamental: the discovery that the universe itself may not be the final frame of reality. This marks the second great turn, one that does not simply shrink Earth, but redefines existence itself. For most of human history, we believe the universe was everything that existed: a single cosmos, a single stage, a single set of rules. But modern cosmology suggests something far stranger: that what we call the universe may only be a region within a much larger, possibly infinite structure. The observable universe is limited not by space, but by time, by the 13.8 billion years since the Big Bang. Beyond that horizon lies a region we cannot see, not because it does not exist, but because its light has not had time to reach us. That boundary is not the edge of the universe. It is simply the edge of the visible. This is where the second revelation begins. Everything we know, everything we can observe, everything we can measure may be only a small fraction of a much larger whole. The universe could be thousands, millions, or infinitely larger than the part we can see. Structures far beyond the cosmic horizon may dwarf even the largest galaxy clusters we know. Earth does not simply shrink into an observable bubble. It shrinks into an unobservable ocean. But the revelation deepens. Inflation theory suggests that our universe may be one of many, each born from the continual stretching of space-time. These universes could expand, stabilize, and freeze independently. They may obey different physics, contain different particles, exist in different dimensions. Some may host stars and galaxies. Others may be barren. Others may collapse instantly into silence. We do not know how many there are. We do not know where they begin or end. We do not know if they interact or remain forever isolated. But the mathematics suggests a possibility as vast as it is unsettling. The universe might be a multiverse. In this expanded reality, scale becomes almost meaningless. Earth dissolves not only in distance, but in possibility. Our world becomes one tiny configuration within an infinite sea of configurations. Its existence is not guaranteed. Its physics is not universal. Its laws are not fundamental. They are local, temporary, circumstantial. The constants that define Earth's structure may be only one version among countless options. This is the second great twist. Earth is not small within the universe. The universe is small within something larger. The idea of smallness transforms dramatically here. Earth is not insignificant because it is physically tiny. It is extraordinary because it exists at all within a reality that does not require it. In a multiverse where most possible universes never produce complexity, ours is rare. In a reality where most universes contain no stars, no chemistry, no atoms, ours is exceptional. And in a cosmos where even life may arise only in brief windows of stability, Earth stands as a phenomenon so improbable that its smallness becomes a reflection of its value, not its insignificance. But there is yet another layer to this twist. If the universe is infinite, or if infinite universes exist, then patterns will repeat. Not metaphorically, literally. In an infinite landscape, every arrangement of matter that is possible must occur somewhere. This means that there could be countless Earth-like worlds scattered across an infinite expanse, some identical, some nearly identical, some wildly different. The idea is both overwhelming and strangely comforting. It means Earth is not alone, but it also means Earth is not unique. And yet, even here, something remarkable emerges. In a reality where infinite versions of Earth may exist, the only one that matters is this one. The one where you are experiencing these thoughts, this moment, this awareness. The existence of infinite possibilities does not diminish the meaning of any single instance. It amplifies it. Meaning becomes personal, local, internal. It becomes something created, not granted. This marks the turning point of the entire journey. Up until now, smallness has been a measure of distance, scale, structure, and probability. But in this deeper framework, smallness becomes irrelevant in determining meaning. The universe does not assign value. Physics does not create purpose. Scale does not create significance. These emerge from consciousness, from the ability to reflect, interpret, and feel. And Earth, despite all its smallness, is the only place we know where such reflection exists. This is the heart of the second twist. The universe is vast, but meaning is not distributed by size. Meaning is concentrated in awareness, in experience, in beings capable of asking questions about their place in the cosmos. Earth may be tiny physically, improbable statistically, and ephemeral cosmically. But it is vast in the dimension that matters most, the dimension of understanding. And as we move into the final chapters of this journey, this realization will shift everything. The question is no longer, how small is Earth? But, why does this smallness matter? The answer, waiting just ahead, will transform smallness from a measure into a revelation. As the vastness of the multiverse settles into the background of our thoughts, something remarkable begins to happen. The focus of the journey shifts once more, not outward into unimaginable distances, and not inward into the machinery of quantum fields, but toward the very experience of being conscious within such a reality. Up until now, the shrinking of Earth has been a matter of scale. But at this stage, smallness transforms into something entirely different. It becomes a lens through which we begin to understand not the universe, but ourselves. The more we peel away the layers of cosmic immensity, the more the universe begins to mirror something unexpected. Fragility. Not physical fragility, but existential fragility. The recognition that everything we hold familiar exists within an impossibly thin band of conditions, circumstances, and moments. Earth is not only a small world, it is a brief world, a rare world, a delicate world. And in the quiet after the second great twist, the emotional weight of this realization begins to unfold. Consider first the nature of time. The universe is not static, it is not frozen, it is not even steady. Time is a river that flows forward, shaped by entropy, by gravity, by motion, by expansion. And Earth exists within a very narrow region of this river. Too early, and the universe would be too hot and too chaotic for life. Too late, and the universe will be too cold and too thin for stars to shine. Earth lives in the middle, a cosmic springtime, a fleeting warmth between the fire of creation and the frost of cosmic emptiness. Then consider the nature of place. Earth orbits a star whose temperature, luminosity, and lifespan fall into the tiny category of stars stable enough for life. Too massive, and the star burns out in millions of years, too short for complex life to emerge. Too small, and violent solar flares sterilize nearby planets. The sun is not just a star. It is a precise compromise, a narrow middle ground in a universe full of extremes. Earth orbits the sun at exactly the right distance for liquid water, within a zone so thin that shifting a few percent inward or outward would freeze or boil the oceans. The moon stabilizes Earth's tilt. Jupiter shields it from lethal asteroid bombardments. Every detail stacks like a fragile column, each piece essential to the emergence of life, thought, and meaning. But this fragility extends beyond biology and astrophysics. There is also the fragility of consciousness itself. The brain, the organ that experiences the universe, is composed of patterns firing across a network of neurons. These signals represent memories, emotions, sensations, dreams. The awareness that contemplates the cosmos is a pattern, a flow of electrical and chemical events occurring in tiny spaces of biological matter. If Earth is a small planet in a vast cosmos, then consciousness is a small flame inside a brief world. A flame that can be extinguished by damage, by chance, by time. And yet, this flame is astonishing. It has taken the universe 13.8 billion years to produce it. Every star, every atom, every law of physics, every motion of galaxies, all the vast systems we've explored, somehow they converge on the emergence of beings capable of asking questions like, how small is Earth? The universe, for all its grandeur, does not know itself. But life does. Earth does. You do. This awareness casts the shrinking of Earth in a new light. Earth is small physically, yes, but it is vast in the dimension of experience. It contains every story ever told, every memory ever lived, every moment that has ever mattered to anyone. No galaxy, no star, no nebula can claim that. The Andromeda Galaxy does not feel awe at its own spiral arms. The Virgo cluster does not remember its collisions. The cosmic web does not reflect on its structure. But Earth holds minds that can. This is where the emotional core of the journey begins to deepen, because smallness, when viewed through consciousness, is not insignificance. It is intimacy. Earth does not need to be large to matter. Meaning is not measured in kilometers. Meaning is measured in moments, in awareness, in the ability to reflect. The shrinking of Earth has stripped away the illusion of centrality. But what remains is something more profound than centrality: perspective. And yet, something else emerges here too. something heavier, a recognition that awareness itself is temporary. Consciousness is not permanent. Life will not last forever on Earth. The planet will change, the sun will change, time will move forward. Species will rise and fall. Civilizations will appear and vanish. Your life unfolds within an interval so brief that it barely registers on the cosmic scale. And yet, to you, that interval contains everything that makes existence meaningful. This paradox, smallness contrasted with significance, forms the emotional foundation of the final act. The shrinking of Earth is complete. The vastness of reality has been revealed. The multiverse looms behind the universe. The future stretches into cold darkness, and the flame of awareness flickers within this immensity. But now the question changes. It is no longer, how small is Earth? The new question, the one that rises from the silence, from the fragility, from the perspective, is this. If Earth is so small, if reality is so vast, if time is so long, and if existence is so fleeting, why does this tiny, temporary world feel so profoundly important? The answer, the true answer, the one the entire journey has been leading toward, waits just beyond this moment, where the universe meets the human experience head-on. There, smallness becomes something unexpected, not a limitation, a revelation. As we approach the final stretch of this journey, the universe stands at its fullest scale before us. Every layer has been revealed. The planets, the stars, the galaxies, the web, the horizon, the multiverse, the quantum fields beneath it all, and the fragile ember of consciousness flickering atop a tiny world. The shrinking of Earth has transformed from a physical concept into an existential one. And now, in this second-to-last passage, the narrative reaches its highest tension, the moment before the truth finally emerges. Because the final revelation is not about how small Earth is. It is about what this smallness actually means. To see it clearly, we have to gather every thread of the journey and weave them together into one coherent picture, one that reveals why Earth's tiny scale is not a flaw, but a doorway to understanding. Begin with distance. Earth is small compared to the planets, the sun, the galaxy, the local cluster, and the universe. But distance alone does not answer anything. It simply places Earth inside a vast stage. Then consider time. Earth is young compared to the universe, and life even younger. But age alone also does not yield meaning. It only sets the chronology. Then consider probability. Earth is improbable. Its physics, chemistry, location, stability, environment, none of them are guaranteed. But improbability alone does not define purpose. It only tells us that we should not expect Earth to exist often. Then consider consciousness, the rare flame that illuminates meaning. But consciousness alone is not the full answer either. It is only one half of the equation, the part that perceives. All these pieces, distance, time, probability, awareness, are incomplete when examined separately. But together, they lead to something profound. Because Earth is the intersection point of all these forces. Not the biggest, not the oldest, not the most stable, not the most central, just the one where all necessary conditions converge at exactly the same moment. Earth is not the center of the universe. It is the center of experience, and that distinction changes everything. The universe does not require Earth. The cosmos is not designed around life, but life is designed around the cosmos. The laws of physics, the constants of nature, the structure of space-time, they are not arranged for the sake of Earth. But Earth exists because the universe allows it in an exquisitely narrow band of possibility. Smallness is not an insult. It is a clue, a clue that meaning does not come from scale. This shift becomes even clearer when we examine the paradox of perspective. From the outside, Earth is microscopic. It does not appear on cosmic maps. It cannot be seen from neighboring star systems. From the viewpoint of the universe, Earth carries no label and leaves no trace. But from the inside, from the viewpoint of living beings, Earth holds everything. Every emotion, every memory, every act of kindness, every moment of beauty, every joy and grief, every question and discovery. All of it unfolds inside a world that, by cosmic standards, is almost nothing. And this tension between cosmic insignificance and personal infinity is what gives Earth its true meaning. The universe provides the canvas. Earth provides the experience. Consciousness provides the interpretation. Together, they form a kind of cosmic equation that reveals the secret behind Earth's smallness. Earth is small so that the universe can be large. Because if Earth were vast, if our world dominated the cosmos, there would be no mystery, no discovery, no awe, no perspective. Vastness gives context to existence. Distance gives meaning to home. Time gives weight to the moment. Probability gives value to the improbable. Smallness allows significance to emerge not from size, but from awareness. This inversion becomes the emotional core of the approaching finale. Earth does not matter because it is big. It matters because it is conscious, because it is temporary, because it is fragile, because everything meaningful happens within its boundaries. This tiny world is the only place we know where the universe looks back at itself. And now we arrive at the final tension, the question that hangs before the last reveal. If Earth is this small, and the universe this vast, and consciousness this fleeting, then why does it feel like everything matters so deeply? Why does a life so brief feel infinite from the inside? Why does a planet so tiny hold so much meaning? Why does awareness, so fragile, so temporary, feel so profound? The answer to these questions is the final revelation. It is the conclusion everything has been leading toward. And in the very last part of this journey, the truth will emerge. Not about the universe, but about the significance of living inside it. Because the smallest things often carry the greatest meaning. And Earth, in all its cosmic smallness, is about to reveal why. In the quiet that follows the long journey outward, something unexpected happens. After all the expansion, all the dissolving of scale, all the shrinking of Earth into smaller and smaller meanings, the mind arrives at a place where distance no longer matters. The vastness of the universe, once overwhelming, becomes still. Not because it is small, but because your perspective has grown large enough to hold it. And in this stillness, the final truth begins to take shape. All along, the question has followed us like a faint echo. How small is Earth, really? We have measured it in kilometers, in probabilities, in cosmic time, in the multiverse, in the fading light of galaxies moving beyond our reach. We have seen Earth vanish in every possible sense. But now, in the final moments of this journey, the answer reveals itself. Not through the universe, but through you. Because Earth is both the smallest and the largest thing you will ever know. It is small in the language of physics, but infinite in the language of experience. The universe stretches across billions of light years, but you do not live in billions of light years. You live in moments. You live in perceptions. You live within the boundaries of a life that feels immeasurably vast from the inside. And this is the revelation. Significance is not assigned by the universe. It is created by consciousness. A star 1,000 times larger than Earth does not feel awe. A galaxy containing 1 trillion stars does not feel meaning. The cosmic web spanning billions of light years does not feel wonder. But you do. Earth does not matter because of what it is. Earth matters because of what happens on it. Because it is the cradle of awareness in a universe filled with silence. Every sunrise you've seen, every person you've loved, every idea you've imagined, every memory you carry. These are not diminished by the universe's size. They are elevated by it. The cosmic scale does not erase meaning. It provides the contrast that makes meaning visible. Against the backdrop of infinity, even the smallest spark becomes profound. Earth is small, yes. But smallness is not the opposite of importance. Smallness is the condition that allows importance to exist. If Earth were the center of everything, if existence revolved around us, there would be no humility, no wonder, no curiosity. It is precisely because Earth is tiny that the universe feels immense. It is because the universe is immense that consciousness feels miraculous. And it is because consciousness is miraculous that your life, this brief, fleeting, fragile life, feels precious. The shrinking of Earth was never meant to diminish it. It was meant to reveal what truly gives it value. Not size, not age, not location. Awareness. Because out of all the stars, all the galaxies, all the possible universes, all the mathematical landscapes where nothing ever becomes conscious, Earth is the place where atoms learn to feel, where matter learned to ask questions, where the universe, for the first and perhaps only time, became able to reflect on its own existence. This is why Earth matters, not because it is large, not because it is central, not because it is permanent. Earth matters because it is aware. And you, standing on this tiny world, looking out into an overwhelming cosmos, you are the proof. The universe does not feel its own vastness, but you do. The universe does not marvel at itself, but you can. The universe does not seek meaning, but you are capable of creating it. So how small is Earth? Small enough to disappear from every cosmic map, and yet large enough to hold everything that has ever mattered. In the end, Earth is not the center of the universe. But in a universe without a center, awareness becomes the center. And that awareness lives here, on this tiny, fragile, miraculous world. A world that may be small in scale, but infinite in meaning.